In 1974, Stephen Hawking made a prediction that he would spend the rest of his life trying to reconcile with everything else he knew. Black holes, he showed, emit radiation, not from inside. Nothing escapes a black hole's interior, but from the event horizon itself, through a quantum mechanical process in which virtual particle pairs pop into existence near the boundary, one particle falling in and one escaping outward. This escaping radiation carries energy away from the black hole. The black hole loses mass. Slowly, over timescales that make the age of the universe seem brief, but it loses it. Eventually, a black hole evaporates completely. The problem, the catastrophic, profoundly unsettling problem, is what happens to everything that fell into it. When matter falls past an event horizon, all the information about that matter disappears from the observable universe. The quantum states of every particle, the exact configuration of every atom, in every molecule, in every structure that spiraled in. All of it sealed behind a boundary from which nothing returns. When the black hole evaporates through Hawking radiation, that radiation is, to a first approximation, random, thermal. It carries no discernible record of what fell in. A library falls in, a star falls in, a civilization falls in. From the outside, the radiation looks the same. The information about all of it appears to be destroyed. This is the black hole information paradox. And it is not just a puzzle about black holes. It is a direct challenge to one of the deepest principles in all of physics. Quantum mechanics, the most precisely tested and experimentally verified theory in the history of science, has a law at its mathematical core. Information is conserved. The total quantum information in a closed system never decreases. You can scramble it into forms that are practically impossible to decode. You can spread it across the universe in entangled correlations too subtle for any realistic measurement. But you cannot destroy it. This is not a preference or a postulate. It follows mathematically from the way quantum systems evolve. It is called unitarity. And if black holes violate it, quantum mechanics, the foundation on which virtually all of modern physics rests, is wrong. If quantum mechanics is right, information is indestructible. Hawking himself, for decades, thought the paradox meant quantum mechanics was wrong at the extreme scales near a black hole singularity. Late in his life, he changed his mind. Most physicists today believe unitarity holds, that information is not destroyed, only scrambled so thoroughly that recovering it from Hawking radiation would require a computation of incomprehensible complexity. The information is there, technically. Which brings us to something even stranger: the holographic principle. In the 1990s, building on work by Jacob Bekenstein on black hole entropy and insights from Gerard 't Hooft and Leonard Susskind, physicists arrived at a remarkable insight. The amount of information that can be contained in a region of space is not proportional to its volume. It is proportional to its surface area. Read that carefully. The information content of a three-dimensional region scales with its two-dimensional boundary. The implication is staggering. Our three-dimensional universe, with all its stars, galaxies, planets, minds, history, and complexity, may be mathematically equivalent to a two-dimensional encoding of information on a distant boundary surface. Not a simplification of the three-dimensional version, an exact equivalence. A different description of the same physical reality, one in which our three-dimensional space is emergent, like a holographic image cast by information encoded on a flat surface. This is not a fringe speculation. The ADS/CFT correspondence, a mathematical framework linking gravitational physics in a higher dimensional space to quantum field theory on its lower dimensional boundary, is one of the most studied and mathematically productive results in theoretical physics of the past 30 years. And what it suggests, what the combination of unitarity and holography suggests, is that even when all physical structure is gone, the information may not be. Even after heat death has flattened every energy gradient, even after Hawking radiation has evaporated the last black hole, even after every proton has decayed, the quantum information about the entire history of the universe might persist. Spread into the correlations of photons, encoded in the subtlest fluctuations of otherwise empty space, present in the entanglement structure of a universe that, to any classical observer, looks like nothing at all. Not readable, not accessible, not useful to any conceivable mind, but there. So let's hold two things at once. 1. All physical structure ends. All energy gradients flatten. All complexity dissolves. Everything we would call the universe, in the sense of things happening, things existing, events occurring, comes to an end. 2. Quantum information, if unitarity holds, is conserved. The record of the universe's existence might persist in encoded, maximally scrambled, physically inaccessible form, long after any structure, any process, any observer is gone. Does this answer our question? Does it mean the universe remembers itself? I want to say yes. I want that to be comforting. I want the preservation of information to mean the preservation of meaning. But I think, if we are honest, we have to go further. Let's ask the question that physics cannot answer. If the universe's information is preserved, encoded in maximally scrambled quantum correlations across empty space, carried in the radiation of long evaporated black holes, but no mind can ever read it, is it real? Is a record that no one can ever read still a record? This is not a physics question. It is a question about what we mean by real. And it turns out, we've been using that word to mean two different things. And at the end of everything, the difference between them becomes the whole question. There is ontic reality, reality as a property of the universe, independent of observers. Things exist because they exist. The laws of physics obtain whether or not anyone is watching. A supernova explodes in an empty galaxy 1 billion years before life appears anywhere. And that supernova was real. It happened. It scattered its elements. It changed the composition of that galaxy forever. Its reality requires no witness. And there is epistemic reality. Reality as it intersects with knowledge, observation, the capacity to be experienced or known. On this view, a universe that is permanently and totally sealed from any possible observation has no meaningful claim to existence in any sense that matters to anything. Existence without witness is what, exactly? A definition, a formalism, a name for nothing. Physicists almost universally take the first view. The universe is real. Its laws obtain. Quantum fields evolve. All of this proceeds whether anyone is watching or not. The universe does not require our permission to exist. But there is a catch that quantum mechanics itself planted, and that we have not fully dug out, and that may not be fully dug out for a very long time. The measurement problem. In quantum mechanics, systems exist in superpositions of multiple possible states until they interact with a measuring apparatus, until they are, in some sense, observed. This interaction, the collapse of the wave function, or whatever it is that actually happens, converts indefinite quantum possibilities into definite classical outcomes. The many worlds interpretation says, no collapse ever occurs. Every outcome happens. The universe branches endlessly. And what we call measurement is our becoming correlated with one branch among many. No special role for observers. Everything is just physics. The Copenhagen interpretation says, the wave function is a calculational tool, not a real object. Reality is what is measured. The question of what happens when no one is measuring is not a physics question. It is a category error. Objective collapse models say there is a real physical collapse mechanism, independent of observers, that kicks in at a certain scale. The universe is ontic all the way down. Other interpretations exist. New ones keep being proposed. None has been proven. None can currently be tested in a way that would decide between them. But every interpretation confronts the same raw fact. Quantum mechanics, as formulated, has a structural relationship between its description of a system and the act of observing it that classical physics never had. Whether the observer is fundamental to quantum reality or merely incidental to it is genuinely, honestly, uncomfortably open. And so our question sharpens. Was the universe real before observers existed? Will it be real after all observers are gone? The honest answer is, we do not fully know what real requires. Let me try to put the weight of this clearly. The universe is 13.8 billion years old. For the overwhelming majority of that time, the first 9 billion years or so, it contained no observers. Stars formed and exploded in empty sky, with no eye to see them and no mind to register their light. Galaxies collided in slow-motion cataclysm, sending billions of stars spraying into new orbits, and there was nothing to witness it. The Earth itself formed 4.5 billion years ago, and for the first 500 million years was a world of molten rock and bombardment, devoid of anything alive. Were those events real? We are strongly inclined to say yes. Of course they were real. We have evidence. The light from ancient stars still reaches us. The heavy elements forged in those stellar cores are in our bodies right now. The craters from ancient impacts are still visible on the surface of the moon. The reality of those events is downstream of us in a causal chain we can trace backward with extraordinary precision. But trace further back, before any rocky planet complex enough to support chemistry, before the first self-replicating molecule, before the first nervous system, before the first photon was processed in something we could call an experience. Were those moments real? We say yes. We assume yes. The physics says nothing about their unreality. But we cannot know yes from within this framework, because knowing is something minds do. And in those moments, there were no minds. We can only know that they were real because we are here now, reading the evidence backward through time. Our existence is what makes their reality legible to anything. There is something recursive here that makes the mind slide. The universe created observers. Observers make the universe legible. In some deep sense, the universe knows itself through us, through every mind that has ever looked up at the night sky and tried to understand what it was looking at. We are, as has been said in different ways by different people across centuries of science and philosophy, the universe becoming aware of itself. In the far future, the last observer will die. There is no path around this. Entropy's patience is absolute. Maybe it happens on the last life-bearing world in a galaxy that has long since drifted out of contact with all neighbors. Maybe the last observer is something we would not recognize as consciousness, a diffuse, cold process running on the final trickle of an energy gradient too faint for us to imagine calling usable. Maybe it is something entirely beyond our capacity to envision. But there will be a last one, and in the moment of that ending, in the final cessation of the final experience, the universe will lose something it has never before lost and will never recover. Not just a mind, not just an observer. It will lose the only thing that was ever experiencing it. From that point forward, the difference between the universe existing and the universe not existing will mean nothing to the universe, because meaning was always ours to make. It was never a property of the vacuum. Now, I want to be precise here, because this is exactly the kind of territory where honest difficulty can slide into melodrama, into a performance of cosmic sadness that is more about the performance than the sadness. The universe does not need us to exist. It did not ask for witnesses. Quantum fields will interact in the cold dark of maximum entropy with the same mathematical precision they demonstrated in the first seconds after the Big Bang. The laws will hold. Physics will obtain. The question is not whether the universe will continue to be. The question is whether it will continue to matter. And mattering, in every sense of the word, in every sense we have ever deployed it, requires a mind. There is no mattering without something that matters things. There is no meaning without a meaning maker. The universe does not find itself interesting. We find it interesting. We always were the interesting part. So we arrive at the final answer, or rather, the final form of the question. When the universe ends, truly ends, and the last observer is gone, and the information has been scattered to maximum entropy, or encoded in inaccessible quantum correlations, or simply surrendered to a dark so complete and permanent that even the word dark becomes meaningless. Was any of it real? Here is what I think. I think real is the wrong word. Not because it fails to apply, but because it is doing two incompatible jobs at once, and at the end of everything, those two jobs finally pull apart and cannot be reconciled. In the ontic sense, yes, the universe was real. Stars fused hydrogen into helium, and that fusion was real. Planets formed and cooled, and in a handful of remarkable cases, in the thin habitable skin of a tiny number of worlds orbiting average stars, something began to move and replicate, and eventually to think.
And that was real. Every thought was real. Every moment of wonder was real. Real in every physical, causal, verifiable sense. It happened. The causal chain leads from the Big Bang to this moment, and every link in that chain was forged in the real. But in another sense, the sense that asks not did it happen, but does it mean anything, we are not looking for a property of space-time. We are looking for a relationship. And we are the other end of that relationship. We always were. The universe is real because we are in it, and we have called it so. That calling, that act of witness, is not a small thing. It is not a footnote to the physics. It is, in some strange and not fully articulable way, the physics' greatest achievement. Not galaxies, not black holes, not the billion-year nuclear burning in stellar cores, though all of that was necessary to get here. This, the fact that a universe that began as a hot, featureless plasma managed over 13.8 billion years of cooling and clustering and burning and dying and exploding and reforming to produce something that looks back at it and says, I see you. I know you. You were here. The universe told its own story through us. We were the ending it was always building toward. And for a while, a cosmically brief, unrepeatable, luminous while, it worked. The universe was known. I started this channel with a simple premise. The universe is too interesting not to understand, and too vast not to feel small in front of.
am not sure I understand it better. I am sure I feel smaller. But smaller in a way that is not diminishing. Smaller the way a person feels standing at the edge of the Grand Canyon, or in a cathedral on a winter morning, or on a clear, dark night in a field with no light pollution anywhere. The Milky Way actually visible as a thing you are inside, not a smudge, but a structure. And you finally let yourself feel what you are looking at. Smaller, because the thing you are inside of is enormous. And you are inside it. You are it, actually. You are the universe paying attention to itself, for a moment, in this particular shape. Here is the last thing. The universe will end. Everything in it will end. The last mind will close, and after that, there will be no more questions. Because questions are things minds ask, and minds will be gone. But right now, in this moment, wherever you are, this is happening. You are here. Somewhere, a room, a commute, a sleepless night, you chose to spend some of your finite, irretrievable time asking the largest questions you could find. And that is not nothing. It is not a small thing. It is not a distraction from the serious business of being alive. It is the serious business of being alive. Every time you have looked at the night sky and felt something move in you, that is the cosmos doing the only thing that lifts reality above mere physics, witnessing itself. The universe will forget us. Everything will be forgotten. The record will be scrambled beyond recovery, or dissolved into quantum noise, or simply released into a silence so complete that the word silence will no longer apply. But we were here, and we looked. And for a little while, looking was enough. Thank you for watching.